One thing that a lot of people struggle with is the circular arrays, so I decided to create a geometry node circular array that works with something like 10 nodes. It's quite simple to recreate, and I'm going to show you how to do that. You can just copy the circular array, place it wherever you want, and you have the controls here. You can change the instance. For example, I will change it to a Suzanne that I have. We can change the radius. We can change the amount of instances. We can change the scale of the instances. We can rotate. And also I added the rotation in other axes. And then also I added this clipping to, you can make like half a circle if you are interested. Let's get started. Okay, we will start by adding the object that will be our circular array. Shift A. You can add any object you like. I will add another cube. And let's rename this circular array or whatever you want, just to identify it. Then I will activate snap. I will change here to face, center, align rotation to target, and project individual elements. I will scale it down to, maybe we can press S, 0.1, enter, then Ctrl A to apply the scale. And now if we grab our object with G, it will snap to the faces of the other object and also align the rotation to that face. That's what we want. So I will place it around here for now. And I will now add another object. This will be, in my case, a monkey. I will scale it down a bit. Ctrl apply scale, and for now I will hide it. Now I will select my C-array object and go to GeoNodes. I'm using version 3.0 alpha, so if you see that you are missing any node, you should download the last alpha version. We create a new geometry nodes. I will call it circular array. Okay, so instead the logical thing would be to use a circle, but since I want to be able to create arcs too, I will use instead a spiral, curved spiral, and I will plug this here so we can see it. At this point we have this. In our case we don't want the height, so we will take this to 0. We also don't want difference between the radius, so I will expose this. This will be my radius. We can see it on this tab. And with N, and going to the group, we can change the name. So I will just call this radius. And I will use the same value for both inputs. So now I can manipulate the radius from outside the setup. In this case, we are not going to use this resolution to distribute our points here. So this will become the resolution of our circle, how round it is. I think with something like 64, we are fine. Now, so we can see what's going on and we can learn a bit more. I will add a point instance here. And here we can select our Suzanne. So we have this at this point. It's using this number for now, but we will change that. I will expose this too, so we can change what we use on our circular array here. At this point, if I use another object, I will add a bolt, scale it down, and I will hide it. I go back to my CArray object, and then we can change this, for example, to the bolt, just to show you that you can select any object here. I will use now a trim curve. We have 2 rotations here, we have to change this to 1. And now with this curve trim, we can move the start and the end. But let me show you with maybe 6. But as you can see, this is not how we expect it to work. So we are going to change a bit this. That's why I use the resolution here. And I will use a resample curve here. This will basically resample, or it's like a remesh for the curve, and will make the amount of counts that we want here. So this will be our real amount of instances. So we expose this. I will move it up, and I will call this instances. Now we have to deal with this double object here. So we have a full rotation here, and I want to divide my rotation by the amount of counts that I have and subtract 1 from the rotation. So what we are going to do is to add a math node. I will use my number of instances. At this point, it's 9. Let's make it 10 to make it easier to understand. I will divide 1. That's my rotation factor here, 0 to 1. And I will divide it by the number of instances. So I have basically the value for the distance between one and the other. Now I will subtract from 1, that's my rotation, this value, 1 distance, and plug this on the rotation. So now we don't have that overlapping. And as you can see, if we increase or decrease, this works fine. And also now we can control the start and ending points of our circle. So you can create like semicircles, arcs, and we will expose this as well. So we have our start and end. Now we want to be able to rotate our Suzanne. So we could use point rotate. We need to be able to access these values separately, so we will use a combine XYZ. And now we can rotate around C. But at this point, all the faces are looking to the same side, and I want to be able to have them looking to the center, for example. So I will use an align rotation to vector. I will change my vector to attribute, and here we will use position. So now you can see that they follow the line. And now if we rotate, we can make them. And now we can also rotate them and make them face whatever we want. And we can expose this axis. So X, Y, and Z. Now we can control the rotation, And also in some cases maybe you need to rotate on X or Y. One thing to note is that the rotations are around the object. That's the object that contains the circular array. So for example, at this point, if we rotate in X, they all rotate to the same side, but you can change that to point and that will make it per point rotation. So now if you rotate on X, they rotate on local axis, and same for Y. The C won't change because it's the same for the object and the instances, but keep that in mind. You can, maybe this one is more likely to be used. And the last thing we need is to be able to scale the point. So we use a point scale. And instead of a vector, we want to use float. And we have a factor here. So we expose that. And you can rename this as you want. Once you do this, if you want to create another circular array, you just duplicate this one, move it, place it wherever you want, and change the values. And that's it. Thanks for watching. I hope you have liked this tutorial and see you in the next video.